All right. Good evening, students. Welcome back for another important lecture on coordination compounds. Last time we have told you that how to name coordination compounds using IUPAC system. Now this is
Yes,
something
sir.
very important and a question will be asked student. We said that we should learn the rules for naming these compounds. And who makes these rules? IUPAC.
IUPSC.
IUPAC has already given rules. For example, cation is named first in positive and negatively charged coordination compounds. Ligands are named in alphabetically order student. And if the ligand is anionic, the last letter is O for neutral and cationic ligands. Same except few names we have given you a table also. Water
Yes,
H2
sir.
is used a lot. Aqua, amine, NH3, double N, CO, carbonyl, nitrosyl.
Carbonyl.
We have oxalato,
Yes, sir.
ethylene, diamine, EN. So these are some of the important ligands which will be asked in the papers. And prefixes mono, dry, tri, etc. are used to mention the number of the ligand students. And if the ligand includes numerical prefix already inside it, then for example, ethylene diamine, it has di already in this. So we will use bis, tris,
This
tetrakis, etc.
tetrakase.
So
Yes,
depending
sir.
the number of ligands which already have numerical prefixes in them students, and oxidation state of the metal which we have in the cation, anion or neutral is calculated and represented by the Roman letters 1, 2, 3. Complex is a cation. The metal will be named as it is. Complex is neutral. Metal will be named as it is.
As it is.
If it is an anion,
8 will be added.
we add 8, cobaltate, nickelate. But in few cases, we have used Latin words for those metals like iron. Iron is
Ferrate. Ferrate.
ferrous is the Latin name of iron, ferrate, gold, orate. So these are some of the important names which we should be knowing students for naming
Yes,
these
sir.
compounds. And we have told you how to name these students. We will give you
Yes, sir.
few questions in order to know how much we have learned student. And for example, here on the screen we have few questions for you students. Why do we do question student? Because they are the backbones. If we are able to do the question students, then naturally what happens that we can answer the question in the paper. For example, student, here we are saying write the, here we have to write the students. If I have to do the A part student, A part of this, for example, this one, you have 30 seconds to answer the question students. What will be the IUPAC name of this? The rules which we have told you will be followed. The rules which we have told you will be followed. This compound, you see, first of all, I have to see is it cationic, anionic, or neutral type of coordination compound. What do you see in this?
It is neutral.
Okay, first I for myself I am saying it is neutral student. ठीक है?
Yes, sir.
It is neutral. There is no charge on it. Positive, negative, nothing. So for neutral, we already know that the, let us see what is the metal here.
PT. Platinum.
So what is the name of that?
It will be platinum only.
Platinum only. Why do I do so much work, student? Because this is a way to learn. Once I can do practice, then I don't need to do all this. Because I don't believe in shortcuts. Shortcuts will lead to always some errors. Some errors unknowingly take place. So we may lose mark unnecessarily. I'm just trying to see how do I can I understand the rules, students. It's difficult to memorize the rules first time, but when I do more questions, then it becomes practice for me and easy for me. So, what are the ligands involved here, student? You have how many NH3 are there? Two.
2.
So, what will be the name of this? Di.
Diamine.
I mean, I'm just writing what will it mean? Diamine. Now, then what is the Cl? How many?
Chlorido. Yeah,
What?
chloro.
Chlorido. IUPAC. And what is the story of this last one? NO2.
Nitro.
Now, here is the story, student. NO2 is what type of ligand, student? Why I gave you this important? This is ambident,
Yes, sir.
ambident
Ambident.
nucleophile. It can attach from nitrogen, you know about it,
Yes, sir.
or it can attach from the
Oxygen
oxygen.
also.
Tell me here which is according to this. They have written N.
So
That
it will be
N is
from N.
attached to the platinum.
Nitrito N.
So what will be that, student? Nitrito. And what do you call this nitrito? Then further, what do you call this, student?
Nitrito N.
Nitrito N. That means this nitrogen is attached to the platinum. Now
Yes.
the alpha, what is the oxidation number of platinum here, student? What is the oxidation number of platinum?
It will be plus 1
Plus one.
because Cl will be minus 1.
Cl is minus one. What is NO2? What is NO2? Nitrito. NO2. What is that? So you have, what is the oxidation state of platinum then?
Nitrito is minus 1 plus 2.
Plus 2. Why? You know that some errors can take place. Again, I'm saying, and only by practice we learn all this. All right, we have done so much work now. That means the oxidation state of platinum here is, student, platinum platinum is in plus 2
Plus
oxidation
2.
state. Now tell me the what is the name of this now then.
It will be diamine.
A comes first, C comes, and di
Diamine.
diamine
Amine.
and
Chlorido.
glow. I will check the spelling because there could be mistake. Chlorido,
Nitrito N. Platinum.
nitrito N,
Platinum 1.
platinum. How much?
2.
Two.
Platinum 2.
You see that there is a lot of work involved in solving the question. Can I write it without doing something? Then how can I answer it just by looking at it? Because oxidation number has to be calculated, students, and this requires work. This requires work, students. Let us do one or two more. What is the story here?
K3.
What type of complex is this?
Uh, this one is this one is an anionic complex.
An ionic complex. An ionic complex. Okay. So first, what is this potassium?
Potassium.
In a complex, cation is written first and anion is written later.
Yes, sir.
That
Potassium.
we will decide what is this K here. You are saying Br2O4. What is the charge on this?
It's 3 minus.
3 minus. This is an anionic complex. Anionic complex. The first is the cation. This is the anionic complex, student. And students, what is the IUPAC name of this C2O4? C2O4.
It is ethane 1,2-diamine.
C2O4.
No, no, तो amine था. Okay, okay, okay. Sorry, sir. Sorry, sir. I'm just doing. 1 minute. It will be this. Oxalato. Oxalato.
Oxalato. Student, sometime in the paper, na, what he will do? He will give only OX3.
Okay.
He gives many times like this.
Potassium.
We are OX like
Trioxalato.
this. They are the same thing.
Salato.
Okay. Oxalato, student. What type of ligand is this? What type of ligand is this? What type of ligand is this, student? Tell me.
Sir, it is C2O4 is bidentate.
Bidentate. Bidentate ligand. Then, students, tell me what is the oxidation state of chromium? What is the oxidation state of chromium here?
+3.
Chromium, if I put X plus 3 into -2 equal to -3, then X is equal to +3. Therefore, chromium is in
+3.
3 oxidations, Roman letter 3. So, students, now how do I write the name? First one, which will cation comes first.
Yes, sir.
What is the cation here?
Potassium.
Okay. Potassium. Then what comes next? Only one ligand is there.
Trioxalato.
Trioxalato. Tri is already there in this. Then what we said? What we have?
Tris.
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 Tris. After tris, tri oxalato, because it's an anionic ligand. Trioxalato. And what is for anionic? Chromium becomes
Chromate.
And what is the oxidation state?
3.
Okay, students. This is the correct answer. See that we have to work. Student, we can't write any answer without working. Okay. If I take students, the next one, tell me what type of complex is this? Cationic, anionic, or neutral?
This is a cationic complex.
How do I say? COCl2En twice. What is the charge then? Cl minus, then it becomes plus.
Yes, sir.
Okay?
Yes, sir.
I said if you will make a shortcut in paper, you are in trouble. You will lose a mark, which is your easy mark. Why students do error? Because they are hurrying up the question answer. Now, the ligands, let us see the ligands. Student, what are the ligands? Chlorido.
Chlorido and
What do you call ethylene diamine or ethane 1,2-diamine?
in 1,2-diamine.
Okay. Ethane
Chlorido.
1,2-diamine. All right, student. Anything else inside? No. What is the oxidation state of cobalt?
It will be.
If cobalt is X, then you have 2 minus 1 into 2. And what is ethylene diamine? 0 is equal to plus. So X is equal to +3.
+3.
Check it. Am I right or wrong?
Yes, sir.
So what will be, what type of is cation? Cobalt
Cobalt 3.
3. Any, did I do any mistake?
No, sir.
Okay, then give me
Dichloride
the
of
name of this complex
312
now. What is
diamine.
cation first and ion later? So, which
Cobalt.
ligand is coming first?
Dichlorido. Chlorido.
Dichlorido. Then
Bis.
base
Ethane 1,2-diamine.
base
Ethane 1,2-diamine.
ethane 1,2-diamine. Then
Cobalt 3 chloride.
cobalt 3 chloride. See, this was trace. I can put it trioxanate. Now, see, this is the way to name these coordination compounds. Coordination compound students. And if I have to name the D part,
It will be C3.
how will I name the D part students?
First of all, this is a cationic complex.
Cationic complex. CONH3 5CO3 CO3 CO3 and we have this is plus and Cl is minus student Cl is minus ठीक है what this is amine
Yes, sir. Then carbonato.
how many here 5
5.
pentaamine this is carbonato only one then what is the oxidation state of cobalt here
It will be X plus 0. Then एक कार्बोनेटो पे चार्ज होता है 2 माइनस माइनस प्लस 3
cobalt this ammonia is 0 what is the carbonate
2 माइनस
carbonate no, okay. So minus 2 equal to plus 1 x is
प्लस 3
equal to plus 3 cobalt
कोबाल्ट 3
3 so then what is the name of these students
पेंटा अमीन कार्बोनेटो कोबाल्ट 3 क्लोराइड
pentamine cobalt
3 क्लोराइड
pentamine carbonato cobalt
कोबाल्ट 3 क्लोराइड
3 chloride okay see this is the way to name this compound student the last one
लास्ट वन इज HG it is a cationic complex
cationic complex
Hg has a charge of
Hg cannot be negative
Hg is positive, so it will be okay. Anionic complex.
anionic complex students that means then what will be the name of the student how it will look like what is the charge on mercury students
Mercury is +1. Mercury 1.
anionic complex anionic complex and what is the SCNO group
It's a thiocyanato S.
Thiocyanato so then what will be the name
Thiocyanato S.
what will be the name of this E part E part student mercury will come first
Mercury 1. Thiocyanato. Tetracyanate cobalt. neutral.
mercury. How many? Tetra,
1 plus X
thio,
minus 1.
cynato,
NATO.
and cobaltate. What is the oxidation number?
Cobaltate. It is -1 here.
-1. How?
SCN is
-1.
+1 X.
There are four. Cobalt is X, then 4 plus 4 into -1
1
equal to -1. So
minus 1.
what is X? Plus 3.
1 plus X minus 4 is equal to X is
Plus
equal to +3.
3.
So cobaltate 3.
Cobaltate 3. That's all.
3.
Then there is nothing. See that names can be difficult to write. Sometimes one minor mistake is over than 0 marks. If you write anything wrong, then it is not going to get any mark. There is nothing here. It is a 1 mark question, students, and you will not get anything, any chance for that. Whatever we say, students, we have to be careful. Here are some of the important ligands which I gave you, because these some of the questions which were given in the CBSE previous papers. These are some of the questions, students, they were asked in the board exam. Tell me, for example, the first question is on the screen, students. What is the IUPAC name of this?
Chromium NH3. Yes, sir. This is Cl3. Okay. Maybe try aqua.
Is it a cationic complex or an ionic complex? First thing.
Maybe like
Is it a cationic or an ionic complex? Students, first question before I do it. H2O3, students. What is the charge coming?
is cationic complex.
It is a cationic complex. All right. How many ligands you have? 3. NH3 means what? You have triamine. You have aqua.
Triaqua.
What is the oxidation state of chromium? What is the oxidation state of the chromium?
3.
Chromium is
3 plus 3 plus 3.
1, 2, 3. Then what is the IUPAC name of this compound?
Triamine triaqua chromium 3 chloride.
Triamine triaqua chromium
3 chloride.
3 chloride. ठीक है?
Yes, sir.
Okay. See that naming, how do we name these compounds? Next question now. If you can do it, you can do fast. We have shown you the method of doing it. Students. How much charge is there? 3 plus.
It is +3.
So, what is the oxidation state? It is a cationic complex.
Yes, sir.
Cationic complex, students. What is the oxidation state of platinum?
X 0 minus 1. It is plus 4.
Platinum plus 4. Cationic complex, therefore, it is platinum 4. Okay. What is the then IUPAC name of this compound?
Pentaamine chlorido platinum 4 bromide.
Pentaamine chlorido.
Chlorido
Platinum 4 chloride. ठीक है? Did I do any mistake or correct?
No, sir.
Okay. Next
It is
question.
correct.
Next question on the screen. No, there is a bromide now. Why did I write chloride? You are saying yes. No? Is it chloride? It is.
It is a cationic complex.
Okay. We have to.
Yes, sir. Bromide. It will be this. Dichloride. Base. Ethane. 1,2-diamine.
That was bromide.
Platinum.
What was here? Bromide. What is the IUPAC name of this?
It will be dichlorido base
Dichloro.
ethane 1,2-diamine platinum 4 chloride.
Some mistake is there. Again, some mistake is there. Dichlorido. What type of ligand is this?
Base.
Then why you did not say base in the first? Base. What we say? You can write ethylene diamine also.
Ethane.
Or
Yes, sir.
write ethylene diamine. Okay, acceptable. Ethylene diamine.
Platinum
Platinum.
4 chloride.
Platinum, how much? What is the oxidation number of
4
platinum?
chloride.
4 chloride. Okay, now is the correct answer. Okay. Next question. Problem is there the internet. What is happening? Internet. Internet problem. Some internet problem could be there.
Yes, sir.
What is the fourth answer?
4 will be base ethylene trace. Trace ethylene diamine co will be A
उससे भी खराब हो गई। हो गया। Fourth one answer completed. What is the name you have given?
Yes, sir. Sir, for fourth it will be tris
Tris,
ethylene diamine cobalt 6 sulfate.
tris, ethylene, diamine, tris, ethylene, diamine, cobalt. What is the oxidation state of cobalt?
Cobalt 6 sulfate.
6. The cobalt can never be 6. Mind it. How it can be 6? What is there? These are 2 here.
6 plus 6.
Plus 6 cobalt is not in plus 6 oxidation state.
Because sir, ethylene diamine is 0.
Array, this is twice. You can see what is the charge on this. What is the charge on this? This is 3SO4. Okay? 3SO4 2 minus. Then this 3 will go on the top of this.
Okay.
So cobalt, what is then 3 sulfate, and what is this 3 plus? You have 2 of that. 2 CO. If I write it small, ethylene 3 plus. This is sulfate. Sulfate.
Okay.
What is the next one?
It will be potassium. Potassium hexacyanoferrate 2.
Cyano or cyanide, both are allowed. Potassium
Nido.
hexacyanide
Ferrate.
spelling should be checked. Student, this
Ferrate
what type
2.
of complex is this? Anionic, ferrate,
This is anionic. Anionic.
anionic complex.
Yes, sir.
This was important. These questions are from the previous board papers. One question is always given, students. One question is always given. You can see that. Unless by practice only we will be able to know and learn more of this. Question number 6 is on the screen,
Okay.
students.
Na2 NiCl4 sodium tetra chlorido nickelate. Mhm. Then,
What type of complex is
two.
this?
Anionic.
Anionic complex.
It will be sodium tetrachlorido nickelate 2.
Sodium Cl tetrachlorido.
Nickelate 2.
Tetrachlorido nickelate. Oxidation state is how much, students?
2.
Okay. NiCl4, this is 2 plus. ठीक है? 2. Okay. Next question on the screen, students.
Sir, this is Cl4 is outside the. Okay, this is inside. Okay. Di-
What type of complex is this, students?
It is neutral.
Okay. See
Diamine
that? Neutral.
chlorido.
I hope you are learning how to write
Yes,
the
sir.
name. No,
Yes, sir.
we follow the steps, there is no mistake. We don't follow the steps, some problem is there.
Platinum 4.
You know, one question is coming. This should be easy.
Yes, sir. This is diamine tetrachlorido platinum 4.
Diamine tetra
Chlorido.
chlorido. Diamine tetrachlorido.
Yes, sir. Platinum 4.
Platinum, what is the oxidation state?
4.
4. This is the correct answer. After you can see now we are able to do better. Did I write any capital letter anywhere?
No, sir.
Yeah, you see the point. All this is important for us. Many students are writing somewhere big letter, somewhere small letter. See, this is if you will see the book, they are writing only small letters. I have not seen big capital letters. Have you seen it?
No, sir.
There is no mention of that, but I am telling you, our attention should be very clear because this will be easiest to get 1 mark, students, because one question will be there, but
Yes,
error
sir.
can be very easily done. Why? Because it's such a long answer. I do some mistake, then yeah, if I spelling mistake is there, then 0. Next question. What type of complex is this, students?
Neutral.
Okay, neutral complex.
Wait.
Neutral complex. Then what is this?
Penta.
CO?
Carbonyl.
Carbonyl. How many are there?
5.
Okay, then the job is easy. Then what is your answer, students?
It will be pentacarbonyl iron.
Pentacarbonyl iron.
Charge on iron will be 0.
You have to answer the question 30 seconds only.
It will be 0 only because
Okay. There's
CO is
no nothing, so
solid.
why should we have doubt, student? My purpose is to remove the doubt, so that is why I give different type of questions. 0 is coming, let it be 0. It will be 0. In CO type of ligands, you will see they will form compounds which will be of in the 0 oxidation state. I mentioned earlier
Okay.
also. In manganese also it will happen. In the case of nickel also it will happen. They are CO is a very good ligand, students. This forms a large number of compounds, coordination compounds, you can see. And they are in the zero oxidation state matter. Okay, next question. Next question, students. What type of complex is this?
It is anionic.
Anionic complex. Okay. This is an anionic complex. What is the charge? You have ammonium ions. And what will be the charge on this complex? Nickel.
Yes.
C2O4 to
Two,
H2O2
two, plus,
2 plus.
minus 2 plus 0 is equal to 0.
Then what we are finding? X
X
plus
minus, hmm, it will be 2 plus 2.
X is plus 2.
Ammonium.
Okay, then what is the name of this? What is the IUPAC name of this complex, students?
It will be ammonium dioxylato, नहीं डाई aqua पहले आएगा डाई ऑक्सिलेटो निकलेट 2
So, okay,
अमोन
what
it
is
will
the
be
answer? Coming ammonium
ammonium diaqua
diaqua.
dioxylato
Hmm.
nicolate 2.
There is a mistake. What is the mistake, student?
Ammonium diaqua, it will be ammonium diaqua, okay, oxalato bis, it will be bis here.
Now you
Bis
check the answer. What I put.
nicolate 2, yes, okay,
Are this where is this?
okay,
This is
yes sir, it will be bis,
but this is bis because it already has bis oxalato. This means there are two oxalato groups. So next one,
it is this CN whole 2, it will be
the last one is more. This is the
diammonium,
difficult one. Here you have a cation and an anion, both are complex.
yes sir,
Both
mm, silver
cation
1
and anion, they are complexes. Now, what then how will we make it?
dicyanide
But one thing is clear: first one is always positive, and second one is negative.
8,
First one is positive, second one is negative. You know, first one is always written cation. What do we write? Cation first, anion then.
yes sir,
That means this first one has a positive charge and second one has a negative charge.
negative charge.
First one is cationic, second one is anionic complex.
Sir, it will be
And the quality of silver, you know, what is the.
1, 1.
So I can write it like this, student. Now we have to think.
Yes, sir.
NH3 to this is
Whole 2 plus
plus one charge and
plus AgCN
Ag
whole twice
and
minus.
is having a negative charge,
Minus.
students. So what is
Yes, sir.
the name of this compound?
It will be diamine silver 1 dicyanido argentate 1.
Diamine.
silver 1,
This is cationic complex. So silver
1,
1. And this is anionic
dicyanide,
complex. Di
cyanido,
Cyanido. Now, what do you do?
argentate,
Argentate.
argentate 1.
Argentate. See the how difficult it was. Even spelling mistake can be there. Argentate one. Okay?
Yes,
Can
sir.
can we see that how much different type of questions were there? Now you tell me, are you having any doubts in these questions, students?
No, sir.
Okay. So this provides us a good amount of confidence to do such questions in the exam.
Yes, sir.
Okay. This was a large variety of the question which were given in the paper, students. These were given in the paper, students. Okay. That actually ends our mainly the naming part, which was very difficult and important for students. It is not difficult, but the question is to learn and to do practice. Because sometimes you see the questions we have never done it, then it will be very difficult for us. Even if I know the rules, I will struggle a lot. As the last question you see, I will struggle a lot. So we have to be able to solve different type of questions, students, and that helps us in appearing in examinations. Every time we are talking about that. The second topic which is coming in coordination compound. Up to now, what you have done, you have discussed what are coordination compounds, what are double salts, what is the difference between simple salt, double salt, coordination compounds. Then I discussed the Werner's theory of the coordination compounds, what he talked of primary valencies and secondary valencies, ionizable and non-ionizable. Then we discussed what are ligand, students. We discussed what is the central metal atom. Then we discussed certain terms involved in the coordination compounds. We discussed ambident nucleophile, always important question in the paper. We are already aware that you are having a sense of the paper now. Ambident,
Yes, sir.
polydentate, EDTA, hexadentate ligands. Such questions are given. Chelation, formation, more stability. Then how to write the molecular formula of the compounds. The most important part in all this, tell me what is the most important part in all this which we are talking about?
Nomenclature,
No, no. In nomenclature, what is the most important thing that we
find
finding the
oxidation state.
oxidation state of metal is very important. That is where some problem comes. So certain ligands which are very typical, which are different, we should be able to know their names as well as the charge on them. Mostly I've been talking of anionic or neutral ligands, and only few bidentate type of ligands have been used, students. Mostly they are the coming in the paper. En, oxalato. Again and again they repeatedly come. So there are few more, but where we have seen most of the questions coming from. What is isomerism, students? What is isomerism? We have learned isomerism in organic chemistry.
Yes, sir.
You learned about structural isomers, chain isomers, position isomer, functional isomers, metamers, all these isomers we discussed in organic chemistry. And you also discussed stereoisomers,
Yes, sir.
optical active isomers, enantiomers, mirror image isomers. Their spatial arrangement is different. Now, in coordination compound, also students, we are going to be asked questions on isomerism. And
Yes.
mainly in this case, student, there will be two types of isomerism, which we will be asking. Isomers in coordination compound, students, compounds which have the same chemical formula but different arrangement of atoms. If the arrangement of atoms is different, what will happen? They will have different properties. Which one? One or more physical or chemical properties. And the two mainly are stereo and geometric, stereoisomers and structural isomers. So, in these two students, what will happen in structural isomer? Structure means, what is a structure? Structural isomers, when I will discuss student, when I'm saying structural isomers, when I discuss the structural isomers, what I'm talking about, the what will happen, there will be different bonds, students, between the atoms, between the
Okay.
atoms. And when I will talk of stereoisomers, the bonds are not the different, but what is happening, they have different spatial arrangement.
Okay.
That means in space, student, their arrangement is different. Students in space, their arrangement is different. The bond between the atoms are the same, but atoms are changing their position in space, spatial arrangement. And certain type of geometries which you mostly come across, students. What type of geometries you experience in these kind of coordination component? Mainly the coordination number, most of the cases either 4 or 6. We are mainly doing that. Right or wrong?
Yes, sir.
Coordination number 2 means linear molecule. Linear means you can rotate it either side. What will happen? So you mainly have students coordination number 4 and 6. There are few more geometries, but most of the time, student, we are going to be discussing all this 4 and 6.
Okay.
So what type of different arrangement they will have, we will see that in the stereoisomerism, in the stereoisomers.
Okay.
There is a metal and 4 ligands. But if all the ligands are same, then what will happen? Can there be isomerism? If all the ligands are same,
No.
you put all the ligands same in this case. Here it is Ml6. You are saying 6 ligands are joining with this. Only when the ligands, what type of this? There are two types of the complexes I told you. Homoleptic,
Homoleptic and heteroleptic.
heteroleptic. Okay. Everything is linked, student. So tell me the coordination isomerism will come in which of the cases? Stereoisomerism will come in which of the cases, student? When I will discuss the stereoisomerism,
Heteroleptic.
heteroleptic. So when I will be talking of stereoisomer, that means the ligands cannot be all same. One of the ligands must be different, students.
Okay.
Unless there will be and more interesting thing, if I say ML3 and there is another one L dash, this ligand is different. Again, nothing is going to happen because one ligand is you can put anywhere. But if I say ML2, L dash 2, now the things will change. There are more things. There are 4 ligands, student. There can be 3 different ligands also. I cannot stop that. There
Okay.
will be such cases also. For example, if I'm saying you can have 3 different ligands, but if 3 ligands and one atom, what will happen? Here also you can get combinations of L4, L2 dash, and you may have L3, L3 dash. So you can have different type of combination, students. L2, L2 dash and L2 double dash. I mean, there can be variation in the ligands,
Okay.
but they have to be heteroleptic to qualify for certain type of isomerisms. Interesting thing,
Okay.
if I take tetrahedral, if the shape is tetrahedral, student, what will happen? If the shape is tetrahedral, then what will happen? In the case of tetrahedral, can there be stereoisomers in this case? We have to think for everything, student, before we answer the questions. What is the shape of a tetrahedral? If I put different ligands, L, L dash, L dash, L, supposing, what will happen if it is a tetrahedral? Tetrahedral means there will be only four ligands. It cannot have more than four in tetrahedral.
Yes, sir.
You can keep on changing the ligands. What is going to happen? All the positions are equivalent.
Yes, sir.
Nothing.
Okay.
You can put here or here or here or here. So there will be no such stereoisomerism. What we talk of in the case of this when there are four ligands, tetrahedral. So tetrahedral complexes will not show what I am saying, geometrical isomers. Here we written geometrical isomerism. What is geometrical? We will show you. Mainly, we will be talking of students cis and trans type of isomerism, which you have heard about earlier also.
Okay.
So there is nothing like cis and trans in coordination number 4 when the shape is tetrahedral. This is all our next part of the study. Let me see what time is it. Because it's beginning. अच्छा ठीक है. The time is running out. We will begin this isomerism is a complete topic in the next class. By now, the formulas of the compound, naming of the compounds is complete.
Yes, sir.
Our next part will be isomerism. There will be one question on isomerism also.
Okay, sir.
And we will be discussing structural isomers and the stereoisomers, optical isomers. Very good questions will be there, which we will discuss. And also, their bonding chapter part is there in the coordination compounds. So
Okay, sir.
we'll continue with the next class. Okay, then, good night.
Okay, thank you, sir.
I think you are quite confident of the nomenclature and writing the molecular formula of the compounds.
Yes, sir.
All types of questions have been completed.
Yes, sir.
Okay, then, good night.
Okay, thank you, sir. Thank you, sir.
Okay.